All right, this is basically working trig word problems, okay? These come up a lot on your Regents exam. So these definitions are pretty important. So the amplitude we've kind of talked about, the distance the sinusoidal model raises and falls above its midline. Midline we didn't talk about yet, but midline is like if you don't have anything, you can see up here with the equations, it's plus C. So if you don't have one of those, your midline is your x-axis. But basically, if you were to cut your trig graph in half horizontally, that's your midline, like right in the middle. The midline, which is why it's called midline, or average y value. So like the middle point of your high and your low point. Frequency, we've talked about it. We've called it the b value. This is our equation that we've solved for it. Again, 2 pi over b is what we've done. The period is how long it takes from the beginning to the end of your cycle. Okay, all those variables are very important. So you can see where they come in to the equation. Again, the only one we haven't talked about is the C, which is the midline. Okay, so here's a real life word problem. The tides in a particular bay can be modeled by the equation of the form D equals A times cosine BT plus C, where T represents the number of hours since the high tide and D represents the depth of water in the bay. The maximum depth of the water is 36, the minimum depth is 22, and the high tide hits every 12 hours. So max and min give us our amplitude, okay? And the fact that this happens every 12 hours means that our period is 12 hours. Okay, on the axis, sketch the graph of the scenario for 2 full periods. Label the points on this curve that represent the high and low tide. Okay, so the fact that we have our high point of 36, our low point of 22, boom, there we go. It hits every 12 hours means that we're going to go out every 4. That's our period. So 12, 24 would be 2. Okay, this is a cosine curve, so we know we start up. You know, then it goes to the middle, then it goes down, then it goes to the middle, then it goes up. There we go. There's our thing. Okay. Now, so our high tides are going to happen here. Our low tides will happen here. Okay. Sorry. Woo. There's our graph. Beautiful, right? So then determine the values of A, B, and C for our model. So guys, if you think about it, amplitude was the difference of the max and the min divided by 2. So 36 minus 22 divided by 2 gets you 14 over 2. So our A is 7. Our period we know, so we gotta kind of work a little bit backwards. We know that it takes 12 hours. So we're going to set 2 pi divided by b equal to the period, which is 12. We cross multiply, we end up getting 2 pi equals 12b. So divide over by 12, we get pi over 6 for our b value. And then our c is our middle point between our max and our min. So the difference, so we're going 7 down from 36. Okay. You can also do midline as max plus the min divided by 2, the average basically between the two. So that would be 29. So therefore our equation is 7 times cosine pi over 6t plus 29. Boom, boom, boom. There you go. Okay. Pause the video if you need to write any of that down. I'm kind of running out of time. Oh, we can graph it on our good old graph equation. Yada, yada, yada. Tanker boats cannot be in the bay when the depth of water is less or equal to 25. Set up an inequality and solve it graphically to determine all points in time. So you would need to be able to graph this thing. We would put in 25, and then we would do the intersection points. Cannot be round all your, so cannot be in the bay at 4. So he can't be at the bay at 4.2 hours. And then 7.8 hours, and it can't also be in the bay from 16.2 hours to 19.8 hours. Okay. Boom, boom, boom. The height of a yo-yo above the ground can be modeled by the equation. Oh, they give us the equation this time. 1.75 cosine pi t plus 2.25, where h represents the height of the yo-yo in feet where ground, and t represents time in seconds since the yo-yo was first dropped from its maximum height. Determine the max and min heights that the yo-yo reaches above the ground. Show the calculations that led to your answer. So again, if we know that our amplitude is 1.75, that means that, and if we have a but, we have plus, we got to do, okay? So our original would be, the height would be 1.75 minus, and then a negative, but then we have to add 2.25 to that. So that means our high is 4 feet, our low is 0.5 feet. Okay. B says, how much does it take to take the yo-yo to return from its max height to the first time? So basically, what's the period? How long does it take this yo-yo to go from the top to the bottom? Okay, so 2 pi over the B, we got 2 pi over pi, which this makes a nice 2 seconds. 2 seconds. Okay. Another example, we got ourselves a Ferris wheel constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground. It reaches its highest point at 130 feet above the ground. The amount of time it takes to complete one full rotation is equal to 8 minutes. A person's vertical position Y can be modeled as a function of time since they boarded. Sketch a graph of its personal vertical from one cycle and then determine the A, B, and C. Okay, so we know that our low point is 5, our high point is 180 because I say that. Okay, so our max minus our min, 180 minus 5 divided by, so we get an A value of 87.5. Okay, so we know that this is a cosine graph, so we know it starts down. Okay, because if you think about it, you don't start up at the top. I know a normal cosine graph to start up. Because it starts down, that means it's just been reflected. Okay, so 2 pi over b, so 2 pi over the period, we know that it's equivalent to 8. Cross multiply, we get b is pi over 4. Okay, our midline is our max plus our min divided by 2. So we'd end up with 5 plus 1, we'd get 185 divided by 2, so you get 92.5. Okay, so our equation would be negative 87.5 cosine pi over 4t plus 92.5. Because again, if you think about it, you're not going to start up at the top point, you're going to start at the bottom point, which just means reflected over the x-axis. So it just means you multiply it by a negative. Way to go. Possible hours of daylight in a given day is a function of the day of the time. In Poughkeepsie, New York, the minimum hours of daylight occurred in the winter solstice is equal to 9 hours, and the maximum hours of daylight is 15 hours. If the hours of daylight can be modeled by using what is the equation's amplitude? Again, amplitude is the difference of the max and the min divided by 2. So 15 minus 9 divided by 2, 6 over 2, which is 3. Okay. Oh, and that's all the word problems I have. So that's just kind of like working with a word problem. You see them a lot in the Regents exam. We'll go over a few more examples, but that's it. Have a great day.